Hello everybody, I'm Mac the Maker, and today we're going to be using a free web-based program called TinkerCAD to design some 28mm scale wargaming terrain. TinkerCAD, www.tinkercad.com, is a free web-based 3D design program that is owned by Autodesk, who are the creators of AutoCAD, one of the bigger names in computer-aided design software. It is their introductory or entry-level product. They have a couple other products past this that we'll hopefully cover in some future videos that are capable of some more work. But on the face of it, TinkerCAD itself is a pretty great program. I'm pretty happy with it. I do quite a bit of work in it. So let's go ahead and get started here. So this is the default landing page after you make an account or log into your TinkerCAD account. This is my recent design. So down here you'll have a bunch of designs. Sometimes they load the preview, sometimes they don't. Down here I've been working on a chain sword there that I downloaded from Thingiverse that I cut up so I could add a couple extra sections into it. Click Create New Design. If you're stuck using Internet Explorer, you're going to have to use the Create Legacy design. There are some huge differences in the regular default editor. It used to be called the beta editor. Is a much better design space than the legacy editor. So if you can use Firefox or Chrome, I would go that route. So go ahead and click that. It'll take a couple seconds. And here is our workspace. We've got our blue work plane here. A piece of paper if that helps you kind of visualize what we're going to be doing and where we're going to be doing it at. You can make this a bit bigger to edit grid. It is by default 20 centimeters by 20 centimeters. You can also change everything to inches. I tend to leave everything in millimeters because at the sizes we're working at, it's a little easier to look at 1 or 2 millimeters versus, 1/72 of an inch or whatever. So I leave these all the same. Go ahead and cancel. You see me moving the work plane around here. These are the camera controls. I'm doing this by holding the right mouse button down and dragging my mouse. If I ever get all kind of discombobulated, I can come up over here to the top left corner. There's the home view. And go ahead and give that a left click and it takes me back to their home view. I can also zoom in and out using the scroll wheel. I can also do most of these into the hardwired buttons into the viewer itself. So if you come over here to this box in the top left corner, you can kind of drag that around as well. They also have the zoom in and out buttons here, and then they have an orthographic view which takes you straight into each axis there. I tend to use perspective for about 98% of everything, and then maybe orthographic if I'm trying to make sure I've got two different models joined together or sections put together correctly, so when I go to print it I'm not getting a gap somewhere I'm not expecting. Up here at the top, if you click this TinkerCAD button, this will take you directly back to the landing page. This says beta. Like I said before, this used to be called their beta editor. They just haven't removed the tag. My designs here, this again will, if you click that, this will pull up everything you've got in your design catalog, gallery, and next to it here, so whenever you make a file, TinkerCAD automatically generates a name for it. Brave, Circan, Lula. To change that, you just click on it, and we'll type in 28mm barrier video. Now, because it is cloud-based, every time you make a change to your design, it is automatically saved. Underneath the title here, these 4 buttons, there are the shortcut keys that I tend to use more often, but you can use the menu buttons here. So copy, paste, duplicate, Control D, that's useful. I don't know if we will cover it in this video. Delete, and then everybody's favorite button, undo, and then the second favorite button is redo. Over here on the right, we'll kind of cover these buttons as we go, but they are incredibly useful. Group and on group kind of finalizes the model and perform some actions that help us visualize what we're doing, and align and mirror are using the computer to make sure everything's centered or justified to how we want to, or we can mirror an item without having to fiddle much with it. One of the best parts about TinkerCAD is this button here, Import. So you can take a 3D file from somewhere else, the one you've designed, or a site like Thingiverse, an STL or OBJ file, and import it directly into TinkerCAD and start messing with it. Export, you can go ahead and once you're done, you can just export the file again as an STL or an OBJ file and send it to your 3D printer slicer of choice. Share, you can email the file or do a couple other things. I tend not to do much with that. It's usually just export. Under these we have the they used to call the helpers, work plane and ruler. We already have a work plane by default. Like I said, it's kind of your piece of paper, but you can adjust that. You can bring a shape down and put the work plane on a different axis, and then that changes things around. I've never actually had to use that, so I don't know much about why you would do that. Ruler, excuse me, incredibly useful, and that'll be our first action here. We're going to pull the ruler onto the work plane, and we're going to do that by holding the left mouse button down while we were hovering over the ruler and just dragging the mouse over to the left corner. If you don't have the ruler down as you pull shapes in, you don't have the measurements, and it's a lot harder to change the measurements. If you're just kind of playing around, you definitely don't need it, but if you're trying to make something fit to a specific size, you're definitely going to need to pull that ruler out. And you can remove it, so if you decide you really don't need it, you can just hit that little dismiss ruler there and it goes away. Underneath this is your menu options for kind of your shapes and actions. Everything we're going to do today is under these basic shapes. There's other design programs call these your primitives. Your box, your cylinder, round roof, cone, polygon. You will maybe notice if you're looking at some of these round objects, they're actually faceted. That is one of the biggest limitations of TinkerCAD. There's a couple workarounds which we'll cover in another video, but it is something to be aware of. Choose text next. So they have a text generator, which is kind of nice, so you can write out your phrase or your string of text, and it automatically does it. There's a couple of fonts that you can choose from. Just pull that out. Not anything you'd be really familiar with, but a sans serif, a monotype, and a serif one. Just go ahead and delete that. Or you can, especially if you're doing single letters or anything, you have individual letters that you can pull onto the work plane and string your phrase together. In another video, we'll cover making text in a different program and importing it into TinkerCAD, so you can kind of choose your font and stuff like that. So symbols, we're not going to run into a lot of these for wargaming terrain. Connectors and extras, all these stuff we'll cover in different videos, but they do exist, and feel free to take a moment and play around with it. Go back up here to basic shapes. So, like I said, we're going to do a jersey barrier here, and I have found at AmericanConcrete.com this fancy little JPEG here that kind of gives us all the real world 1:1 scale dimensions of a jersey barrier. Now for 40K, I'm doing about 1:40 scale, 28 millimeters nominally, 156 scale, but if you've ever played 40K, GW kind of does whatever they want with their scales. So I tend to use 140 for the terrain because it looks a little beefier and fits a little bit better with the aesthetic of the rest of the things going on. So I have already taken the liberty of creating a spreadsheet with the 1:1 dimensions broken down into all the popular wargaming scales. So here's my 140, 156 or 28 millimeter scale, 172 or 20 millimeter, 1/100th for 15 millimeter, and 1/285th for 6 millimeter. We'll probably, so this one's going to be in 140 scale. The next one I do will probably be in 1/100th for Flames of War and that type of thing. So let me go ahead and minimize that. I'll go back to TinkerCAD here. So let's go ahead and start building our Jersey barrier. So we're going to start off with a box, and we're just going to pull that onto the work plane like we did with the ruler. So we just hover our mouse over the shape, left click, and drag it on. When we do that, a whole bunch of stuff showing up around our box. Because this is a three-dimensional program, remember, you'll now have the x-axis, the y-axis, and now the z-axis, or the vertical axis. By default, everything you pull into TinkerCAD is 20 millimeters. So around the perimeter of the object, we have these white boxes with black outlines, and in the middle of each axis here, we have these solid black boxes. The white boxes with black outlines are our two-dimensional manipulators. What that means is I'm going to hover my mouse over one of these boxes here, left click, and move my mouse. And as I move it, I can change the dimensions in the x and y axis. And if I slow down and do that, you can kind of see the dimensions change there. The solid black boxes are our single axis manipulators. So same deal, I hover my mouse over, left click, and as I move my mouse, I'm just making this box longer in the y axis. However, to confuse the situation on the top, or if you're looking at it from the bottom, you get this white box with a black outline, which should be a two-dimensional manipulator, but it's not. So when we click that, it just makes the z-axis longer. My assumption there is it will help it from the white box with the black outline as opposed to a solid black box. Will help it be a little more visible and usable that way. Above that is the little black arrow shape, and when we click that, it will physically lift the object off the work plane. And as I do that, over here, this field becomes active, and this is your height off the work plane, or I guess it could be under the work plane as well, because you can put things under the work plane. And that is, of course, denoted by the negative in front of the number. To change any of these dimensions, I can also simply click into the respective text field and click on it. It'll highlight the number and type in my new dimension. So in this case, I want this to be flat on the work plane, so I will type 0 and hit enter, and there we go. I'll zoom back real quick over to our Jersey barrier, and we're going to look at this. So we know that the base of our Jersey barrier here is 10 feet long by 2 feet wide. And I'm going to go back to my little scale here, and I know I'm going to need this then at the 140 scale in millimeters to be 76.2, or exactly 3 inches long, by 15.25. So I'm going to leave this up in my second monitor, but go back to TinkerCAD, and let's go ahead and get this. So our x-axis will be our length here, so 76.2 by 15.24. So looking at our scale drawing here, we see that the base of our Jersey barrier here, the little rectangular shape, is 3 inches. Now, doing our math and stuff, that ends up to be just slightly under 2 millimeters. I'm going to go ahead and flub that number and make it 3 millimeters, both for printing and kind of just to give it the correct appearance as opposed to direct scale. So I'm going to come back over here to TinkerCAD, click in the z-axis, and hit 3 millimeters. And there's the base of our Jersey barrier. That doesn't look like much yet. So I'm going to go back to our picture here, and the next shape we're going to try to get is this kind of pyramidal shape here. So I'm going to come back here, and luckily they have the perfect option already for us, the roof shape. And I'm going to left click that guy and just drag him on the work plane. Now he is at the wrong angle for us to use. So that'll cover how to change an angle of an object. So as you kind of look around the shape, you have these curved black arrows. These are your angle manipulators, and depending on what view you're looking at an object, 1, 2, or all 3 manipulators will be visible. So I'm going to kind of look around, and I need to change my roof here to be parallel with the rectangle we made. So this arrow looks like it's going to do the job. So I'm just going to left click on the curved arrow, and I can do this 2 ways. I can hold the left mouse button down and move my mouse. If I keep the mouse close to the object that I'm turning, you'll see it does these 22.5-degree jumps, which if you're trying to just get to like 90 degrees or 180 degrees is by far the best method to do. But if you're trying to do stuff a little finer controlled, if you pull the mouse outside the ring that surrounds, the little protractor ring, it will allow you to do single increment adjustments here. So I'm going to go ahead and get it to 90. So we have this, the correct orientation, perfect. And I'm just going to drag this kind of onto our base. It doesn't have to be perfect. So, in fact, I think I got that a little too close. Let me just, there we go. Now we know this is going to also be the 76.2 millimeters long, the 3 inches long. So let's go ahead and get that there. So I'm going to go ahead and we're going to lift this roof shape, the triangular prism shape here, off the rectangle. And again, to do that, I'm just going to grab that little black spear shape and just kind of pull it up. So I can look at my chart, or I can just click on the rectangle again. Maybe, there we go. And I know that's 15.25, so I'm just going to click our roof and click 15.25 again. And you'll notice when I do that, the alignment shifts. So I can do the alignment again. I can draw the selection box, or if you have a lot of going on, a lot of shapes on here, and the selection box will just be too big of a tool, you can simply hold the shift button down and click each shape. And now you can tell they're both selected again because of the blue halo around everything. Must not have clicked it. And sometimes the alignment marks kind of move on you. There we go. Go back to our drawing. We see this shape last for about 10 inches, more or less. Again, we can't perfectly copy that kind of curved angle there, but again, we'll get it close. So 10 inches tall. I'll pull up my little cheat sheet. And we know 10 inches is, in 140 scale, about 6.3 millimeters. So I'm going to click the triangle, and I'm just going to click over here and hit 6 millimeters. Well, we're starting to get somewhere. And go back to my drawing, and we know this last part here is looks like 19 inches, 1 foot 7 inches. So we see that 19 inches comes out to about 9 millimeters. So we're going to remember that number. Come back over here to TinkerCAD, and we're going to pull a box out here again. This time I'm just, so I don't have to hold on to that number in my memory for too long, I'm going to hit 9 for the vertical height, and we know it's going to be 76.2 long again, because that's how long they all have been. But we need to figure out what the y-axis is. So I'm going to come over here and see that 6 inches is 3.81 millimeters, or we'll say 4 millimeters. So let's go back to TinkerCAD, and the y-axis is 4 millimeters. Let's move that around. Good. I'll kind of drag this over, and we'll use the align feature here in a second. And then I'm going to drag. Now this is going to be a little less precise. I'm going to grab my arrowhead shape and pull up, and I want to kind of truncate that pyramid shape. Get this all aligned again. There we go. And we have a very Christmassy looking construction barrier. and fix that. We can do a couple things, but the reason it does that is by default all these shapes come out in whatever color they show up as in the basic shape generator over here on the right. Change that. We can click each individual shape and come up here into what they used to call the inspector, and there's a solid or hole button. We'll cover the hole in a minute, but you can just click the solid button and choose whichever color you'd like. This will have no effect on how it prints, just kind of like a black and white copier. It comes out in whatever color filament you have in the machine as opposed to whatever's on the screen. I'm going to go ahead and click gray, and I can do this each individual one, or I can select everything and come over here and choose gray, kind of give it that shape. Now I'm looking at this and I feel that this vertical part here, this vertical rectangle, isn't long enough. It just doesn't have the right feel for me. And that's a lot of times in scale work more important than being truly accurate, especially for wargaming and stuff like that. We're going more for the impression of the object as opposed to a perfect tiny scale replica. So let's go back to my little scale drawing, and so our overall height then should be 2 feet 8, which was the 32 inches, which is, pull that dude up, 32 inches, so it should be about 20 millimeters tall altogether. So let's go back to TinkerCAD, and to find out if the entire shape is that, I'm going to draw the selection box over everything, and that'll give me, so it looks like putting this rectangle, the top portion of the wall, kind of under the pyramid has caused that problem. That's probably about 4 millimeters there. So I'm just going to go ahead and select away, because if I start messing with these numbers, it's going to change the overall feel of the whole shape and skew that. So I'm going to click off to the side and just click my top rectangle here, and we're going to add 4, so we're going to make that 13, and there we go. And now that's starting to look the business, and that's perfectly usable as a jersey barrier in a game. I'd be perfectly happy with this on the table. Quick coat of primer, or just gray primer or gray spray paint, and a quick wash, and you're good to go. But there are some other details that we can add. So you have the forklift pockets. I'm sure the grim darkness of the 41st millennium still uses forklifts, so they have to move these things somehow. And then these little lifting holes. Now the lifting holes I could go either way on. At 2.5 inches, they're fairly small. They're going to have to be exaggerated, and I don't know if it'll add a lot to the finished model. We'll show you how to put them in, but anything, if you do a true 1/56 scale, it'd probably show up, but anything smaller than that, I wouldn't even waste your time. You're more likely to end up causing printing issues than anything else, or the slicer will just completely ignore it. So we'll put in both. I'll show you how to do both. But if you're doing if you're worried about how to do these, if you're worried about your printer or them not showing up, I wouldn't even worry about it. Like I said, they don't add much. So we know our fork pockets here are 10 inches wide, and we know that base was 3 inches tall. So we'll mimic that on the model. So let's go back. So let's pull up by cheat sheet, and we know 10 inches is about 6 1/4, 6.3 millimeters. So TinkerCAD. Let's pull out our box here, and first thing we'll do is make the x-axis 6 millimeters, and we're going to make the z-axis 3 millimeters. And what we're going to do for this is I'm going to show you 2 ways to do this. It kind of depends on your printer and a couple other things, but let's go ahead and get these put in first, and then we'll get to that. So I'm going to pull this over. So what we're going to do, and this is one of the nicest features of TinkerCAD, is make this a hole. And with a single click, we're now cutting a shape out. And other programs call this a Boolean. You usually have to pay a decent amount of money for a program that does this well. TinkerCAD does it pretty well, so I'll often design an item in a different program and then import it into TinkerCAD and use it to cut the holes and kind of finish the model. So what does a hole mean? Well, it simply means that there is a lack of space in this defined shape. Now on the blank work plane that doesn't really mean anything because you're already in a lack of space, but as soon as I kind of put this in the model, you'll show that you'll see that you get this little shadow indicator here. And what that's going to do is, I'll jump ahead real quick just so you can kind of see it, is I'm going to click on the base here and click on the hole. I'm going to come up here and hit group. This might take a second. But now, peekaboo, we can see all the way through. I'm going to hit undo because we need to get these aligned a bit. So there were 2 fork pockets. Close my cheat sheet there. And it looks like they are 40 inches apart, or 1 inch, or 25.4 millimeters. So we can use that. Let's go back to TinkerCAD. And then I'm just going to click my little fork pocket shape, and I'm going to hold the control button, and I'm going to peck the D button real quick. Doesn't look like it did anything. You may catch the quick orange flash that shows up on the screen. That's duplicated our shape though. So now I'm just going to use my right keyboard key and kind of shift the object over. And now you see we have 2 identical shapes, and this nowhere near right yet, but that kind of gives you the idea. Now as I'm moving these, you'll notice they're moving in millimeter jumps. Each one of these small squares here is a millimeter, and we scroll out a little bit here. My distance from the ruler, which remember we put in this bottom left corner here, is moving at a millimeter a click. We can change that. We come down here to the snap grid, and we can change that to 0.1, and that's usually useful for pretty fine movements. So we said we were 40 inches apart. So we want to get that in the middle. And let's see, let's go back to my drawing real quick. And it looks like they don't give us a dimension from the edge. So we're going to have to do a couple tricks for that. So what I'm going to do is, I don't necessarily want to draw some boxes to measure. So I'm going to select our base and our 2 pockets. I'm going to come up here to align, and I'm going to click this, and what that's going to do again, it is going to perfectly center both of our boxes. And then I'm going to click off to the side. I'm going to click a single box. And so we said it was 25.4 millimeters, so we'll half that, and we'll say 13 millimeters. I'm going to come back down here to the snap grid, change this back to 1 millimeter, and I'm going to click my right arrow 13 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to do the same with the other pocket, but going in the opposite direction. I could also have zoomed out a little bit and come to the ruler and just type the number in there. But so now we should be 26 millimeters apart. And one of the great failings of TinkerCAD is there's not like a snap to ruler that I could just use to measure. But we can just pull out a box here, and I'm going to type in, we say 26. Click just that base. Don't click the pockets. Click our measuring box here, and then hit align and center. And I'm going to clear my selection. Click my box and just move it in real quick. And so if we look here, it looks like we got 2 in a hair and 3. So let's move this one, and there we go. I'm sure there was a mathematical way of doing that, but this was, for me, just as quick. So I'm going to click our little ruling box and hit delete. Alright, so we have our fork pockets in. They look pretty right. Again, if they're off by a tenth of a millimeter or so, you're probably not going to be able to tell. Now for printing, this is a pretty easy shape for any printer to do, any FDM printer. The only issue that you might have is the fork pockets going all the way through. You may end up with some spaghettiing in there, or some other issues that you may not want, especially if you don't want to put like supports in there and have to worry about the supports. You probably, something like this, you want to probably print 5 or 10 depending on how big your printer is at one time, and just be able to pop them off the plate, give them a quick wash and paint them. You don't want to remove supports or anything like that. So if you want to avoid that, we can just leave these as kind of shallow depressions to give the impression of the full fork pocket without the issues printing that. So to do that, I'm going to kind of go straight up, or I can come back to my top, make sure this is orthographic view, and so now we have a straight top down just like you were drawing, and I'm going to wheel my pocket out a bit, and let's say as soon as you click, you kind of change the orthographic. So to do that, and this works in a perspective view, if you hold down your middle mouse button, you kind of recenter the object, and there we go. Makes it a little bit easier to see. So I'm going to click my fork pocket again, and you can kind of see here is the outline of our pocket once it's inside the shape. So I'm going to just kind of pull this until there, and I'm going to come back to our single axis manipulator here, and I'm going to shrink this so it is about flush, with the outside of our base. And now I know this pocket is 2 millimeters deep, and that honestly is almost probably too deep even for if you were just going for the impression. So let's go with 1 millimeter, and looks okay. Then we're going to do the same thing over on this pocket. As we're going to pull it down just a bit, get this flush with the front, and just for consistency's sake, hit 1. And now we need, let's come back over here. Click that pocket, hold shift down, click the second pocket, hit Control D to duplicate those, and then I'm just going to use the up arrow key, kind of move these. Alright, I'm going to change my view so I can get a little better idea of where we're at exactly, and click in just a couple times. I had changed my snap grid to 0.1 as well to make it a little bit easier so you're not jumping in. And those look pretty good. I may be able to go in a, nope. Alright. So now, I'm going to look underneath. You're only going to have this small overhang here, as opposed to the 2 large gaps that may cause problems. My printer does it okay, but I totally can see why other printers wouldn't, and why borrow trouble if you don't have to. So we're just going to leave that like that for now. And then for the last part, which is totally optional, is these 2.5-inch lifting holes here. We'll show you how to align to other objects using these. So let's go back to TinkerCAD, and jumped ahead of myself there a little bit. 2.5 inches is 1.6 millimeters. So let's go back, and we're going to pull a cylinder out now. So let me zoom out a bit, and we're going to pull a cylinder out. Like I said, as you do that, you can kind of see by default there are, I guess, 20 sides. You can move this slider here on the inspector to 64 sides. That makes it a little better. But you want at least like 128 sides, if not more, for it to have the visual impression of a perfect cylinder or perfect circle. But at this size, we're fine. It's not going to be a big deal. So I'm going to go ahead real quick and change my orientation to, here we go. I'm going to keep the mouse close into the shape because I just need a quick 90 degrees or negative 90 degrees in this case. And maybe get a little bit closer. Okay. Now you'll notice that we still have the X, Y, and Z measurements, even though this is a cylinder. And cylinders are usually done with just the diameter and the height, or the Z-axis. I run into this teaching this program to people all the time that aren't used to graphic designs, but remember their geography class with diameters and stuff. Got to throw that out. You still have an X and a Y axis that have to be matched to have a perfect circle, or as close to a perfect circle as TinkerCAD will. Because if you don't, let's go ahead and make our X-axis 10 here. And you end up with an oval. And that may be what you're looking for. If you're trying to get an oval, that's how you do it. But you need to remember that both axes need to be the same if you want a perfect cylinder. So we said this was 2.5, and we're going to change the Z to 2.5, and perfect. Go ahead and leave this at 20 real quick, and I'm going to drag it around, kind of get it kind of close to where I want it. Change my view a little bit, and we're going to pull this up a bit. Now I'm not going to go for whatever the exact measurements were. I'm going to align these holes based on the fork pockets with their spacing in the middle here, and then align it with the middle of our rectangle here to get them kind of spaced where we want. So I'm going to change this to a hole, and I'm going to hit Control D, not Control Delete, and just drag the second one. Again, kind of just eyeballing it. Now, I'm holding the middle mouse button down to kind of move the center. And let's go ahead and use this orthographic view and zoom out. All right. Now to use a different, so I want to align these holes based on the fork pocket and not necessarily the left, center, or right justification that TinkerCAD allows you by default. So to do that, I'm going to hold Shift, click on this fork pocket, and then click on my lifting hole, align, and I'm going to click this middle button here because that corresponds with the middle of the fork pocket. And now that's perfectly aligned with the middle of the fork pocket. Same deal, Shift with the fork pocket, Shift with the lifting hole, align, center. And then clear my selection, Shift on the rectangle that we made the vertical portion of the wall with, click the holes, same deal, align, but this time we're only going to do the Z-axis alignment to make sure they're kind of centered with that guy, and click. We don't need these holes going all the way through. We definitely don't, because that will cause some printing issues. So just like the fork pockets there, I'm going to go back to my little top orthographic, click on the cylinder, click the Z-axis, and just kind of pull it somewhere in the middle for right now, and grab the other one and get it flush with the outside of the wall. Same deal over here. Yeah. And for this one, I'm going to go and even say, make sure that's, I'm going to use the down arrow to make sure it's cutting all the way through the outside surface there. So I'm seeing this shadow shape. So we need, looks like it's this one over here. So that was at 0.6, that's close enough, but for consistency's sake. And looks like it moved it. There we go. Click on this guy. So it's a little deeper. Looks like it's pushing it into the wall, so I've got to arrow out a bit. Just enough to where you can kind of see the shadow shape. And then I'm going to hold Shift and click the other hole again. Control D for duplicate. And mouse up through. And change my perspective. And there we go. I'm going to draw my selection box one last time around the whole shape. Kind of pan around and look at our handiwork. Not too bad. I'm going to come up here to this button here, the group. You can also use Control G. Like I said, this finalizes. This turns our shape into, or our collection of shapes into a single shape. So I'm going to hit group. And depending on what you're doing, it can take a couple seconds. This was fairly simple, so it was pretty instantaneous. But there is our jersey barrier. Not too shabby. And when you're done with it, you wanna 3D print it. You're gonna come up here to export, and depending on what you're doing, make sure you either have everything in the design, or if you have just a single item that you had selected and wanted to print, then you obviously use this selected design. And then download in STL or OBJ. This is a fairly simple shape, so STL will do it just fine. And there comes my dialog box, and I would hit save. That's not where I want to save it, but I'll have this printed up here in a little while, and hopefully have that added to the end so you can kind of see what it looks like. I hope you guys enjoyed the video. If you did, like and subscribe, and I'll be seeing you soon.